So today's session deals about game playing concept in AI. Game playing is one important concept, one application of your AI. So with respect to our syllabus or our constraints, we need to understand how game playing can be applied with respect to your artificial intelligence. So what is the main theme of this game playing in AI? Why there is a huge amount of focus, or why game playing has a focus on AI? How AI is related to some game playing? This is what is the understanding what you need to have with respect to today's session. So everybody of you mostly it might be a small game or it might be a bigger game. It can be a high level game. Most of you, almost 95% of you would be interested to play games. So as a software engineer or as a technical development team member, you need to understand how this can be happen. So it's not only playing a game, because even a children at small lower ages are playing all the possible games. So with respect to that, how we need to understand how AI will be part of a game playing. What is the actual theme of this game playing? That's what we need to understand as part of today's session. Okay. Yeah. So games have it's already we have said that games are very simple to implement with respect to programming, because games have very well defined rules with respect to any intelligent machine development. Adding some intelligence to a system, you need to have a predefined or well defined rules. Then only it will be easy for us to add some intelligence to a machine. It might be a robot, or it might be any game, or it might be a puzzle. You need to define all the possible rules. Then only it will be easy for an intelligent machine to understand what is the background theme, and how it can play with a player. So the games can be a single one-on-one player. If you are taking a suppose if you are taking a small example, small game of Ludo, the very common game by even individuals of children, everybody. So they will be having a chance of playing with four players. You can play with two players or three players, and if nobody is there, you can play it with respect to system also. That is possible. So how this is being developed? What is the theme behind this? So there will be a well-defined rules which can be implemented programmatically. That's what is our understanding. You need to write programs. You need to develop some interfaces. You need to add some animations. You need to add all the possible things and make a game look attractive, interesting. You will add some levels. So for each level, there will be set of constraints and set of rules. You need to develop those rules properly. And also interfaces, whatever you're going to develop, will also be it looks simple. It need to be simple. So interfaces required are usually simple. That is the reason everybody is now focusing on AI with respect to game playing. AI is having a major focus now, and also many human expertise is already available. So it can be a shooting games, or it can be a racing games, it can be a small puzzles. Already many games are already developed. That's the reason we are having a lot of expertise, which means predefined libraries, predefined programs are available. So it makes the next coming generation, the work will be very easy for them. They can simply take these all game codes or cheat codes, whatever it is, everything can be taken and it can be implemented very easily now. So that's the reason everybody is now focusing on game development with respect to your AI. And also games provide a structured task wherein success or failure can be measured with least effort. That's very simple, because so it can be, as I said, the previous example, a Ludo game. So once all the four coins are inside your home, the game will be ended. So other person opponent will be taken as loss or failure. So it's very simple to understand about this success or failure with respect to games, and that's the reason most of the people are now trying to have a focus on game playing with respect to AI. Everybody is now trying to create more user-friendly interfaces with a very simple rules. That's how games have been coming to market very easily. So this is the small history of gaming in AI. So how actually the basic gaming, the already discussed concept in previous sessions like tic-tac-toe problem with respect to chess game, how it can be applied. The initial concepts what we have discussed about AI, it deals with at that time we have explained about how chess game has been developed, how a small puzzle games have been developed. In the same manner, talking about many years, starting from 1956, which is called as Dartmouth Conference, the birth of AI, till date, there are a lot of games developed technically with respect to puzzles, with respect to a number of aspects. So here is a small overview or a picture of what happened previously with respect to your gaming. So people who are trying to focus with respect to your gaming, it can be mobile application gaming or it can be high-end gaming. You need to understand about what is the history, how this has been coming to market, what is the difficulties faced. All these need to be understood, evaluated. Then only it makes you all think about the next stages. That's how we need to think. Okay, so here you can see from 1956, you can see Samuel's Checkers AI. This is one important game which is developed by IBM in the 1956. Next, Bernstein's chess. So chess was the initial game which everybody focused in 1956 only. In 1958, that was the first fully functionable chess AI developed by Bernstein. He was the person who has developed that. Later, again in 1967, MacHack, again a chess AI beats person in tournament. That was one development. So it was a not a complete development at a time. There was a step-by-step improvement in each phase. In 1974, there was a game name called as Kaisa, the first world computer chess champion. It was named as Kaisa. In the same manner, 1968, 62, 1992, there were different games. You can see here CNN, convolutional neural networks, which is like similar to your functioning of your neuron, how from each node to other node it can be traversed. So initially they started with a single player. Later they moved with a multiplayer approach. Likewise, there was a lot of improvement. So in 1993, you can see Monte Carlo Go, the first research on Go with stochastic search. So while explaining about hill climbing algorithm, we have heard this word called as stochastic search. So with respect to hill climbing, there are four types of searching mechanisms. That was stochastic search was one important phase. So that was the concept applied to this game in 1993. So again in 1996, there was again improvement in this game. NeuroGo was one important concept which has been developed by some other person with respect to all the convolution neural networks. That was the theme behind that. Again, 1994, Chinook, again, checkers AI, draws with world champion. So, likewise, everybody takes the example of chess game because in a chess game, there are n number of keys, n number of people trying to, there are a lot of moves applied with respect to the boxes available as part of chess. So, initially, IBM tried to focus there and it has success with respect to that. That's how now 2014 DeepMind, Google buys deep learning AI company for $400 million. So this was the how every industry is trying to focus with respect to gaming, and there are a lot of improvements. Okay, yeah. So now, with respect to this game playing, let's discuss about the insights of the basic things of your game playing. So John von Neumann is the called as the father of game theory. So he was initially he has taken a lot of efforts with respect to game developments, and he has succeeded in many aspects. That's the reason he has been termed as father of game theory. Okay, you need to remember this name, guys. Next, the term game means a sort of conflict in which, yeah, so there will be individual players, as I said, there can be a group of players, there can be a human and system interface. Likewise, there can be a number of possibilities. So game theory denotes strategy for a game. So how you need to game pass a level by level procedure. All the strategies, whatever you're going to adopt as part of your game playing, that will be taken into consideration. So some games needs can be with respect to a tree approach, some can be with respect to a graph approach. So this all depends. So only one player move at, so that's a definitely thing, right? with this, if I are taking a Ludo game also, I have got some sage 598. Any doubts? Yeah. So only one player can take a move at each turn. That's how it can be possible. At the leaf position, when the game is finished, assign utility to other player. So once my turn is completed, we'll be moving for the next player. In the same manner, once the game is completed, utilities will be assigned to each player. Like there will be a rankings also, who has won, who has lost. These all things can be done. If there are multiple players, you'll be given rank 1, 2, 3, 4. At the end, you'll be having some losers. That's how games playing has been emerged. Yeah. So if I am taking about two-player games, it can be a chess game or it can be any other two-player games. They will be having some initial conditions. The initial conditions are each player has a global view of the board. Definitely, if I want to play a chess game, one person to other person, you need to have a understanding of each and every icon. It can be application with respect to your gaming. Any game, you need, if you are talking about two-player games, you need to have a complete global view of the board or the system what we are going to ensure. Next one is zero sum game. Any game for one player is a loss for the other. Definitely, if one person is gaining, other person will be lost. So that is +1 and -1 will be taken as 0. This was what we have discussed when I discussed about tic-tac-toe problem. So the sum should be equal to 0. Sorry. Yeah. So game playing is considered as an important domain with respect to your artificial intelligence. So with respect to developments of n number of algorithms, game playing also plays a major role with respect to AI. So games doesn't require much knowledge. You need to define the basic rules, and once you define the basic rules, it automatically makes you understand with respect to gaming. And according to the levels, what we are going to define, if you are passing the level, it will be a winning condition, else it will be a losing condition. And the next point here is the searching methods like BFS and DFIs. BFS might not be accurate here because it leads to a high branching factor. That's the reason BFS is not considered as the appropriate approach for game playing. We can use a depth first search algorithm. That's what we will be discussing in the upcoming explanation of your game playing. Okay, this is something important, guys. You need to have your understanding. What are the major components of game playing? So when I discuss about the game playing, the basic set of rules, there are two major components. One is plausible move generator. So we have also discussed this with respect to your tic-tac-toe problem. Yeah, so the possible move generator, it is used to generate set of possible successor positions. So whatever search techniques we have learned previously, it can be your A star, it can be a hill climbing, it can be a greedy approach. So whatever the approaches you have understood till now, there also you will be initially having looking at all the possibilities. The example, what we discussed about Jaipur and Delhi problem, there you are having two paths, and that is the possible outcomes, whatever you are going to say. So starting from the source node to the destination node, you will be looking into all possibilities. That's what we call it as plausible move generator. And next, you will be having second important component called as static evaluation function generator. It is called as a utility function. So based on the heuristic or based on the constraints, the statistic function value for each and every move is being made. So it will be generating what is the path. Suppose if I say I am having two paths, and if the cost of first matrix is less and second matrix is more, I will move to the first path. That's how utility functions will be applied as part of your next upcoming approaches. The static evaluation function gives a snapshot of a particular move. Definitely yes, it will be trying to focusing on what is the next move, and you will be having an understanding of, if I move to this position from source to destination, if I use this path, the cost might be less. That's how static evaluation function can be used. 8399A9 having sign in problem. Okay, ask them to try with other accounts, Shashank, in meanwhile. Okay.
వాళ్ళు అన్ఇన్స్టాల్ చేసి మళ్ళీ ఇన్స్టాల్ చేశారంట సార్, అయినా అవ్వట్లేదు.
Okay, one second. Yeah. So, what are the important strategies with respect to your game playing? So, as already said, game playing, there are two major components, and with respect to that, we are having two different algorithms which we need to discuss as part of game playing with respect to our syllabus. So, there can be a number of strategies, but these two algorithms need to be understood by everybody if you want to understand about your game playing strategies, also how game playing can be implemented. So the first one is MinMax strategy, so which we have discussed when we talked about the initial stages of your AI. There how to discuss about your TikTok toy problem, and also missionaries and cannibals problem. There we have discussed about this MinMax strategy. And also the next concept what we will discuss is about alpha beta pruning, which will again rely on your MinMax strategy. So these two algorithms or these two strategies will be very, very important when you are talking about your game playing. For today's session, we will discuss about your min-max strategy, and in the next session, probably we will be discussing about your alpha beta pruning. So once I complete these two things, we will be completed with the unit 1 syllabus of your AI. Okay. So now let's discuss about what is this min-max search procedure. So as already said, the min-max problem is discussed by in the previous sessions. Let's again have a recap of what this is. Min-max approach is the most commonly used technique with respect to your game playing. Why? Because you'll be having a tree-like structure or a graph-like structure where you'll be having one step as minimum and when minimization, other step as maximization. Let's understand about that with the example in the next slides. Yeah, so here it is a depth first and depth limited search procedure. So you need to keep as I said previously, breadth first search cannot be used with respect to your game playing. You are going to apply the concept of DFS. That's why it is called as depth first and depth limited search. You need to keep this technical understanding with respect to your algorithm. Once you're writing examinations, you need to use this terminology. Yeah, it is used for games like chess and TikTok toy. As already we have seen, what we call as O and X will be available with respect to that. And if there is a three elements, same elements in a row or column or diagonally, it will be considered as win. Otherwise, it is considered as loss. So these 2 points we have discussed previously. Like move generator is it will be saying all the possible steps, and static evaluation or utility function it will be saying what is the next stage we need to move on and is it feasible or not. So it returns a value depending upon the goodness from the viewpoint of the two player. Yeah. So these two things which we have discussed here are the same. What I am talking about them here again. So you need to keep these two things in your mind when I am talking about min-max search procedure. Okay. Yeah. So now let's look at a small example with respect to your min-max search procedure. So here this is a tree which is having a root node called as A, subnode called as B, C, yeah, D, E, F, G. Likewise, you are having a small tree structure here, and at the end you are being allocated with some values. Yeah, this algorithm is a two-player game. Is an example of a two-player game. So we call the first player as player one, second player as player two. If you can give your own names also. Initially we call it as player one and player two. The value of each node is backed up for its children. Yeah, so at the end of the tree or the complete children node, child node, you are having some value. That value will be called as a backed up value. For player one, the backed up value is the maximum value of its children, and for player two, the backed up value is the minimum value of its children. This is very important, guys. This is where we'll apply your min max strategy. If a player one is starting the game, he will be having the maximum value, and next player 2 will be taking the minimum value. Let's see about this without confusion in the upcoming slide. Yeah, so it provides most promising move to player 1, assuming that player 2 has make the best move. So when I am playing a chess game or when I am playing a TikTok game, you'll be having all the different possibilities with respect to your game. So player 2 will be assuming that player 1 has applied the best move, and he will try to beat him with his move again. That's how the game goes on, and at the end, one of them will be either winner or a loser. So it is a recursive algorithm, as same procedure occurs at each level. So there is no change in each level. There is a level by level. The algorithm will be a recursive algorithm because the procedure is not going to change here. Okay. So we assume that player 1 will start the game. Four levels. With respect to this tree diagram, you are having four levels. Okay. So starting from player 1 till again player 2, again player 1. So likewise, there are four levels generated. The values to the nodes, you can see here H, I, J, K, L, M, N, O. These are the values allocated to these nodes. The values to these nodes is provided by the static evaluation function. That's what we have discussed here. The static evaluation function will be giving the values with respect to the final nodes. Yeah. So now how to understand about this min-max strategy. Level 3, you can see here level 1, 2, 3 and 4. Yeah. So level 1 is the top level. A node will be the level 1. Level 2 is the B and C. Level 3 is D, E, F, G. Level 4 are the complete children nodes. So you need to first initially look at level 3 guys here. Level 3 is maximizing level. So all nodes of level 3 will take the maximum values. So because level 3 is the maximum, so here you can see at the position D, you are having two children, H and I. So among these two children, I has the maximum value. That's why it is taking the maximum value as 22. Okay. So whenever you are saying as maximizing, it will take the maximum value. Look at the level 2 here. Looking at the node B, you are having two children for B, that is D and E. So because level 2 is minimizing level, it will take the minimum value, not the maximum value. Okay. That's why the value is taken as 12. And here among 25 for node C, you are having two nodes F and G. 23 is taken as the minimum value. Again, if I look at the level 1, it is a maximum. So depending on the number of levels you are having, one of them will be maximizing level, other one is the minimizing. Again, level 3 is maximizing, level 4 will be minimizing. So depending on the number of levels you are having, it will try to move each level by level. And at the end, this means in this diagram, the root whatever the tree whatever you are seeing, level A should choose C to win, because at the maximizing level you are having two nodes B and C. Because it's a maximizing level, it is taking the value or the path called as C. This is the background process which will happen with respect to your min-max strategy. Now let's understand the same concept with respect to the TikTok toy game once more. Yeah. So looking at this picture, now you'll understand what is again you'll just recall what is the TikTok toy problem which we have discussed in the initial stages. So there you can see a person is having taken a value of O, other person takes the value of X. So if somebody wants to win the game, he need to keep his values, it can be X or O, in a right position. It can be a row, all three should be equal, or a column, all should be equal, or diagonally they can be equal. That's how a game need to progress, and one of them will be definitely called as a winner. If there is no if two players plays cleverly, and there will not be any chance of winning a game. That's how that call as TikTok toy is an unbeatable game with respect to your AI, with respect to a player and a system game. So here at the initial stage, you can see at the level 1 you are having three children. That is called as the minimum value. So here you are having the value of 0, 0 and -1. Among these three, -1 is minimum. That's why it has chosen the path of -1. So again, talking about the next level here. Here, if you are talking about in the level 2, the maximizing level, for every node you are having two possibilities. Here, because it's a maximizing function, and -1 and -0 are at the level. For 2 you are having 5 and 6, for 3 you are having 7 and 8, for 4 you are having 9 and 10. So the path can be selected anything here, because both the values are same, v equal to -1. So I'm talking about the last branch, guys, this one. Okay. So here, because the moves are leading to a solution which can be diagonally or column wise, it is leading to a solution. This path is selected by this algorithm. Other paths are not selected because according to the min-max procedure, it is not leading to a game. Here you can see at the node number called as level 11, you can see the value diagonally also it will be leading to a game. But yeah, so it is not meeting the criteria of your min-max condition. That is why it's not taken. Only this path has been selected. This is how min-max strategy will be applied to your algorithm. Okay. So this is what about today's session, guys. We need to understand about what is the min-max strategy. In the next session, we will be discussing about your alpha beta pruning. Okay, so that's it for today's session. So next session we'll discuss about your alpha beta